All right, this is our last lesson for the perimeter and area unit, and today we're going to be looking at composite figures, which basically means you take two shapes and you combine them to make one new shape. That's not our regular shapes that we've looked at. So we're going to look at how to do perimeter and area for those. And we're also going to look at area of shaded regions. So like you'll have one shape inside another shape, and you're trying to find the area in between them. And so a lot of these is multi-layered things, like you've got to do a couple of different things to get the answers. And so I'm going to show you like a general idea of what you need to do, just with these two examples here for composites. And then we'll look at the shadeds next. Okay, so we're going to find perimeter and area for the figure. So looks like we've made a rectangle and then put a triangle on it with it. So what I like to do is, if especially when we do areas, you can like section off where one shape ends and another one begins. Okay, so this is our rectangle right here. And so this, because it's a rectangle, we know that opposite sides are congruent. So this 12 is going to come over here. And then, of course, this 16 from up here is going to come down here. Okay, now notice this 24 that's here on the bottom, it goes from the edge of the rectangle all the way to the point of the triangle. All right. Now we know that from here to here is 16 because of the rectangle. So what's the rest of this? Well, first of all, that's going to be the height of my triangle. And then if the whole thing is 24 and this section of it's 16, that means there's 8 left. So that's the height of my triangle, and I'll have to use that later. Okay. Right. So let's look at perimeter. So remember, perimeter is when you go around the figure. So you're essentially just going along the edge and you're adding up all those sides. So you can go in any direction. So I'm going this direction. 16 plus 12 plus 16 plus, and then we go up this side of the triangle. And notice that there's a tick mark here and a tick mark here. That means they're congruent, and so if this one's 10, this one's also 10. So that means we add 2 10s. Then we just add all that up. And when you add all that up, it's going to be 64, and that would be centimeters. Okay. Now for area, I like to do it I like to space out what I'm doing. So let me show you what I'm talking about. So the total area is going to be the area of this rectangle plus the area of the triangle. And I wish I could make a triangle symbol look decent. Anyway, so area of the rectangle plus the area of the triangle. So we're going to add the two areas together. Okay, so I'm going to leave room right here to do the final work. So I'm going to come down here. So the area of my rectangle, and you can write it just like that because I know what that means. Remember, area of a rectangle is length times width. So we're going to do 12 times 16. That's length times width. And when we do that, we get that is 192 centimeters squared. Okay, then we do the area of the triangle. Remember, area of a triangle is 1/2 base times height. So look at the triangle right here. Your base is actually going to be this 12 right here. Okay, so that's going to be your base. And your height is the 8. Notice I did not use the 10 because the 10 doesn't tell me anything about the triangle other than it's a side. It's not the base or the height, so I'm not going to use it. And so 1/2 times 12 times 8, that's going to be 48 centimeters squared. And so I'm going to come back up here and I'm going to add these two numbers together. 192 for the rectangle plus 48 for the triangle. That's going to equal 240 centimeters squared. So that is the total area. Okay? Not too bad. Okay? And some of the ones you have are like that. So they shouldn't be too bad. Now, this one, it's a little bit more involved. Now, you don't have one necessarily as involved as this one. Okay, but I wanted to show it because on something like the ACT or the K-Prep testing, they could have one like this. So I wanted you to at least see one. So as far as our shapes go, we've got a half circle or a semicircle on top of this trapezoid. Okay? So let's start with perimeter. So I always do perimeter first. And this perimeter is going to be a little bit different because you've got to go, let's say you start here at the 15, so you go down the 15, up across the 48, and then you come up this side that we don't know yet, so we'll have to find it. Then you go around this part of this half of the circle. So you'll need to use the circumference formula there. Okay? So let's first find this side right here. And I can do that because first I need to transfer this. I can transfer this 15 over here. So I can make a right triangle. Okay, so that's 15. And then what is this length going to be right here? Because what I'm having to do is I need to use Pythagorean theorem to find this side. So I got to make sure I have the other two sides of the triangle in order to do that. So this section right here is actually going to be 18. And how did I get that? Well, I know that all the way across was 48, and this much of it was 30. Well, I had this much left. So 48 subtract 30 gives me 18. Okay? Now I'm going to use a squared plus b squared equals c squared to find that length. That is going to be my c. So 15 squared plus 18 squared equals c squared. You can type both of those in your calculator at once. So that is 549 equals c squared. Take my square root. And I get that it's about 23.4 because it's not perfect. And you can round it. Okay, so this section right here is 23.4. Now again, remember you're probably not, I don't think you'll have one this involved on your homework, but I wanted you to at least see it. All right. So I'm going to start adding 15 plus the entire 48 plus the 23.4 that we just found plus, and then I got to add this circumference. Well, first we got to remember that is only half the circle. Okay? So we can do the whole circumference first, which is what I always do, and then I'll take half of it when I get done. Okay? So I'll come down here, and the number I'm going to add is right in here. This is for the half circle. Okay? Circumference, and in this instance, I'm going to use the diameter times pi version because look, they gave me the diameter of my half circle. They gave it to me as 30. So I'm going to say it's 30 pi. And when you multiply those two together, you get 94.2. Okay. Now remember, that is all the way around the entire circle. We've only got half the circle. So I had to take that net number, 94.2, and I only need half of it. So I'm going to divide it by 2. That gives me 47.1. This is what I'm going to add in here, because that's how long it is around my circle. Okay? And so we'll add all those numbers up, 15 plus 48 plus 23.4 plus 47.1. You add all of them together, you get 133.5 meters. Okay? So that's the perimeter all the way around that shape. Now we got to do the area. So let me kind of section off my paper here. Give myself some room. Okay. So the total area, remember I said earlier, it's a semicircle, half circle, and a trapezoid. Okay. You could do rectangle plus triangle if you wanted to, but I'm just going to work it as a trapezoid. So it's going to be the area of the trapezoid plus the area of a half circle. Meaning we need to find the entire area and then take half of it. Okay? You can almost think of it as a sector, like we did earlier in the unit, area of a sector, like a pizza slice. But I think in this application, it's just easier to do the whole area and take half of it. Okay, so I'm going to leave myself some room to actually add my numbers. I'm going to come down here and find what those areas are. So area of the trapezoid. So remember, a trapezoid's area is 1/2 the height times base 1 plus base 2. So 1/2, my height of my trapezoid is 15. My bases are 30 and 48. Multiply all that together, it's 585 meters squared. Okay, so now we'll do the area of the circle next. So I'm going to do the total area first. So total area of a circle is r squared times pi. Now, I need r. This is diameter. Diameter is 30. Okay, I need half of that. So half of that is 15 squared pi. And so you multiply that as a decimal and you get 706.9. Go ahead, you can go ahead and round it. 706.9. Now remember, that's the total area. How much of it do I need? Well, I need half. So I take that number, 706.9, and divide it by 2. And you get 353.5, roughly. Okay? So now we're going to take the trapezoid area plus the circle area. So 585 plus 353.5 equals 938.5 meters squared. So that is the total area of that figure. Okay? So that's your composite figures, like when you just stick two shapes together. So you could have just up here like we did with the first one, scroll my paper. You could have just two regular shapes put together, or you'll have one shape and then a piece of a circle, which they love to do on ACT or K-Prep. Okay, you might have a half circle like we did here. you could have a quarter circle. So instead of doing half the area like we did here, you could do a quarter of the area, so you would have to divide it by 4. And then, of course, you could have triangles, squares, rectangles, parallelograms. I don't know if they'll give you one like that, but they could. Just all the shapes we've talked about. Okay, so that is composite figures. Now we're going to go look at shaded areas. All right. So shaded areas are different. Instead of adding the 2 areas, you're actually going to subtract the areas. It should be a smaller amount. And so the big idea for a shaded area is you go to the outermost figure, the one on the far outside, and its area comes first. Then you come to the inner shape, the innermost, the one inside. Find its area. And then you do outside minus inside. Outside minus inside. I'll show you what that means. So on this shape here, let's do shaded area equals. So you could, if you wanted to, break it up like this and do it that way, but I just think that's too much work. So here's what we're going to do. We're going to connect for this specific one. We're going to connect this up here. So now we've got this 24 by 30 rectangle on the outside. So that's going to be our outside. Area of the rectangle, subtract, that's a really big subtraction sign, subtract this inside piece, which looks like a square, because 3 of them match, so the one has to match, minus the area of the square. Okay, so I'm going to leave myself some room to do the work. Come down here, area of the rectangle. Area of a rectangle is length times width. 24 minus 30. Wow, that is not 24 minus 30. That's bad. 24 times 30. That's going to be 720 millimeters squared. And then the area of the square, 20, because remember a square is the side times itself, so 20 squared, that's 400 millimeters squared. And so we'll do the rectangle minus the square. 720 minus 400 equals 320 millimeters squared. Okay? Shouldn't be, I don't think that one was too bad. Okay? So now this next one, I've taken a square. Now how do I know it's a square? Because every side length is the same. And so I've taken this square and I've inserted 2 pieces of one circle. So I've cut it off. We're trying to find how much area is left in those curved triangle things. All right? So the shaded area. Now the outside piece is the one on the far outside, so that's going to be our square. Area of the square. Subtract. Now, these are 2 half circles, right? This is 1 half of a circle. This is the other half of a circle. But if you think about it, it's like you've cut the circle in half, the same circle in half, and stuck both halves in here. So that's really one whole circle. So we're just going to treat it like one whole circle. Not a half circle, quarter circle, anything. We'll do the whole circle. Okay, so make a note down here. 2 halves is 1 whole. Sometimes you'll have to do that. You'll have 2 halves that come together and make 1 whole. All right, so leave myself some room. Oops. Area of the square. Side length is 10, so 10 squared is 100 centimeters squared. The area of my circle is radius squared times pi. Now, what's my radius? Well, remember, the radius is from the center of the circle to the edge. So it's just that piece. So if you think about it, if it's a square, every side is 10. So this whole thing is 10. That means the diameter of my circle is 10. Okay, so my diameter is 10. That means that my radius is 5, because I need half of it. So we're going to do 5 squared times pi, and that's going to be 78.5 when you multiply and round centimeters squared. And so the shaded area is going to be the the square, subtract the circle. And that leaves us with 21.5 centimeters squared. Okay? So the key to remember for area of shaded regions is the outside minus the inside. Okay? Outside minus inside. And that's it. That's all we have. So I think what I'm going to do, yeah, your assignment, there's 12 problems. And we'll have 2 days to do it. So you'll make sure to watch the video all the way through and then complete your assignment. And as always, if you have questions, just let me know.